All right, everyone, this is Tim. I think we'll be starting here in about a minute or so. I just wanted to make sure Warren was here. Oh, great, Warren is here. Now we can begin, actually. So, so we don't have much to say, and we'll just kick in right away with stuff. So, Suzanne, if you want to kick to the next slide. Benno is getting better. He is on the mend, so that's good. He's recovering from this thing.
We can, yeah, okay. We can go ahead and get into it now that I have figured out the unmute button.
Yeah.
The Suzanne and Tim show. All right. We can go ahead and swing right into it then.
So if you want to kick to the next slide.
Yep. There we go.
There's that one. Of course, and then one more. The note well with our policy and procedures. You should have probably seen this a whole bunch by now. Give it a look through. Let's jump to the next one. This is just for one person. Warren, this is your reminder. I just wanted to give you a heads up. Willem has done his work, so it's up to you now. Okay, thank you. Next slide.
Hold on. Yes, Warren?
Yes, Warren?
Wait a minute. When was the new version submitted?
Just a couple hours ago.
Never mind, back on the rock. Bye.
Yep. Okay, thank you, sir. This is how we communicate with our area director. So thanks. And our agenda is Willem's going to talk. He's got some hackathon results he wants to give out. And then we've got three new pieces of work sort of thing. So there you go. And we'll just kick right into that. Willem, if you're ready.
Yeah, let me grab the slides.
Oh, can I present myself?
Give it a shot.
Yeah.
Give it a shot. See what happens.
Okay.
Okay, let me shut off sharing then. Give me just a second. This is why we don't always do that. All right. There. You should be able to share now. There you go.
Enter screen queue, it says. Oh. Yes, I really want to share. And then this one. All right. So these are the results from the DNS hackathon. Okay. So recently, the DNS org, the DNS Operations and Analysis Research Center, set up a chat service. And many of the people that I would normally meet at the hackathon table are in there. So I thought it would be good to ask there if people wanted to participate in the hackathon. There's also a public channel, so I've put it on the hackathon wiki page as well. So people that were not already on this chat service could join as well. And 14 signed up, which is maybe not as much as a in-person hackathon, but still a good number. Though you have to, unlike the in-person hackathon, people were also still just working and having meetings, and so it was a bit of an in-between affairs thing. Well, the first hack we worked on was the DNS error reporting. Roy will present on the draft later, but it's basically like extended DNS errors. But instead of reporting to the querier, the errors are reporting to the authoritative where the broken thing is. So here you see how that chat service worked in practice. Roy asked for, do you know about broken zones? Which a few people responded on. And then he requested if someone maybe could write the authoritative side of this draft. And sooner said than done, this was written in NSD and is currently running on ns.nlabs.nl. So if you send the option, or at least the option with ID 51281, which will act like the option, it reports a server to which you can submit the error. And also, which in this case is report.nlabs.nl. And on that server, so the errors will normally be reported with a DNS query. So this server will show the log of the DNS queries it sees. So it can help with the development of this option in the resolvers. Resolver implementations should be not that hard, given that not PowerDNS, Unbound all have extended DNS error branches already. So, but also during the hackathon, there's a lot of discussion about this, focused discussion about those standards. And so we wondered how authoritative would respond if resolvers would just use that option, and how we could measure what the impact will be if that would be done. So that's a good result as well, I think. Future research into what the impact will be for this option. Another hack we did was the message digest for DNS zones. There was already an excellent proof of concept implementation written by Dwayne with LDNS, but it was a bit cumbersome, and at the hackathon we made a implementation integrated with LDNS sign zone and LDNS verify zone. And then it was already Friday and the hackathon was over, but before the hackathon, some of the participants wanted to work on interoperability testing for the catalog zones. So we decided we would continue over the weekend with the hackathon and also last week with interoperability testing for catalog zones. Yeah. So here's the text saying, well, we could still continue trying to do this next week. Yeah. And because not has the draft implemented, at least the interpretation of catalog zones since version 3, which is released last September. And PowerDNS already had a proof of concept hack called PowerCats, based on Mukund's original draft. Which was created 4 years ago. Only NSD did not have implementation yet, but 8 years ago, NLNet Labs would have a product which was called Credence, which was based on NSD3, which allowed a zone to be verified before it would be served. And this was basically, it was just NSD, which spawned external program like LDNS Verify Zone or ValidNS. And if that would return successfully, then it would be served. So the last 1.5 years, we've worked on porting this to NSD4. And I've used this branch to interpret catalog zones and deploy the zones in the catalog accordingly. For that, also, I wanted to request a domain name for interoperability testing, the zones.cat domain. And luckily, it was the 15 years anniversary of the .cat top-level domain. So I could get the domain with a discount for only €5. I did have to argue how this was connected with Catalunya. But I just said, well, it's for testing interoperability of catalog zones, and that was fine too. So here you have an example in how that feature of verifying before serving in NSD is configured. So you see that it's calling the LDNS verify zone. And in below there's a piece of the log file showing that it successfully not only verified DNSSEC, but also the zone MD record in zones.cat. Yeah, so I decided to also use that domain name, or we decided to report on all the things which are going on surrounding Zone MD. So here you have the results of interoperability testing between all the different implementations. That worked well, I think. There was also interesting discussion on if it would be a good idea to convey the serial number of the zones in the catalog with the catalog zones. But I think we have to post a message to the DNSOP list so that you can, or we can all discuss this amongst each others. So what we learned. So it was not the same as an in-person hackathon. In-person hackathon has better ad hoc conversations and social interaction. People are not working or on other things at the same time, but I think it was still worth it because we had some implementers focus on the standards. And yeah, I think we gave good input to the work group. So that's basically it. Here you see the list of people that participated. And that ends my presentation. Back to you, Suzanne and Tim.
Yeah. Any questions, comments, ideas for what to do next time for the hackathon? All right, I don't see anybody in the queue, so can go on to the next. Let me just queue up let me get the screen share going, and it's Roy Aarons and error reporting. All right, and that should be visible. Roy,
all right,
next.
Yes, can you hear me?
Yep.
Great. So good morning, good evening, good afternoon, good night for some of you. This is a presentation about the draft that I've written with Matt Larson about DNS error reporting, and the idea is based on extended DNS errors reporting instead of next to reporting to the stub resolver. Maybe this information can go to an authoritative server. So next slide, please. So what is the problem? So this is a bit of a story. You all know this, but I'm going to tell you anyway. The DNS is loosely connected, fault tolerant, configure and go, and any warnings and errors are buried in logs of recursive resolvers. And we all know this. And then came DNSSEC. Next slide, please. And with DNSSEC, DNS still loosely connected, but a little bit more error prone. And you now need to stay after you configure it because things might go badly. Still, any warnings and errors are buried in a log of recursive resolvers. And because of all this, the DNS is slightly more, next slide please, slightly more fragile. So what is it that we can do about this? Next slide please. And with this, I mean, this is the real issue, that these things, these warning and errors, are still buried in logs of recursive resolve. We want to get it fixed, not buried. So what is the real problem statement that I'm trying to fix? Next slide. The problem is when a resolver encounters an error and does nothing, right? It is not that it does nothing. It can now report to the end user using extended DNS errors. It's not that it does nothing. It should do nothing in terms of resolving more, because if it's broken, a resolver can't fix it. So in a sense, that's good, but we want to. Sorry, I thought I was interrupted. Willem, can you turn your mic off, please? Thank you. Okay. So next slide, please.
There you go.
Thank you. What if the resolver can notify the operator/domain owner? Now, that's an interesting thought, of course. At least I think so. But before we do that, sorry, next slide, please. Before we do that, there are some requirements that we need to keep in mind. Since the kernel is already hurting, the reporting should be very lightweight. We shouldn't have any additional complexities. We don't want to send email for every error. We don't want to create PDFs, no whois lookups, no shaming, no sending to mailing list, etc., etc. We don't want to have any guesswork. Because we basically don't know who owns what domain. No guessing what the cause of the failure actually may be. So no heuristics, no trial and error, etc., etc. Next slide, please. So how are we going to do this? Well, we'll set an error report. All right, where you want to send this? Well, we can't send it to the authority server of the broken domain because it's broken, right? And we also can't send it to the owner of the domain because we have no clue who that is. Remember, we don't want to burden the poor resolver with secure whois, RDAP, etc., rich email clients, all that nonsense. So we're going to introduce a new concept here. Next slide, please. And that's the reporting agent. Sorry, next slide, please. I just saw the term idiot before my name. Sorry, that was not that funny. Anyway, especially not early morning. How are we going to send this? Well, we're going to send an error report to a reporting agent, and this error report is just another DNS query. So how do we send this to the reporting agent? How do we learn about this reporting agent? Because we don't want to do another round trip to a broken server. Well, every query can basically have an EDNS0 option, right? That basically indicates that the resolver can handle this kind of reporting. If the authoritative server then indicates it can do this reporting as well, then it can include, piggyback basically, a reporting agent domain in the EDNS0 option. Next slide, please. Well, then what happens? Well, if the response can't be computed or can be dealt with, or is basically presents an error, then the resolver can send a query that's set up as follows. It basically has a bad queue name, the queue name it asked for, where it got a broken response to, and then an underscore error as a separator, and then the agent domain, which is in this case ao1.error.com. That ao1.error.com basically learned via an EDNS0 option. I apologize, I should have used example.com. I will change that for the next presentation. And it can also prepend the queue type and error, but you get the idea. So all of these responses, all of these error reports that are sent out, the responses to that can be cached, and that caching then helps against sending too many reports. I don't want to specify too deeply how a resolver should all do this, because that's up to the resolver itself. But the reporting agent is basically an intermediary, and there's an analogy to that, and that's intermediaries for DMARC. I assume some of you know how DMARC works, so I'm not going to go into that. But that's where the concept stems from. Next slide, please. So does that really work in the real world? Well, on the reporting part, we, and I say we as me and a few colleagues, when we did the Trust Anchor rollover with the community, we had reports going to root servers about which Trust Anchor users had configured. And so the reporting part actually works. What these root servers then subsequently did, these authoritative servers subsequently did, is sent a report to a dedicated name server by appending rfc8145.research@icann.org to a Trust Anchor report. So that kind of reporting does work, at least for the Trust Anchor part. On the EDNS0 part, well, EDNS0 options do work, so there's really nothing new here. Of course, there are many little caveats that in theory I could go into that now, but I don't have time for that. So there are many little caveats documented in the draft. I've talked to a few friends and colleagues about this idea, and many of you have come with interesting security, privacy-related things. I hope I've included that now all in the draft. The next version will come out soon. We oh, sorry, next slide, please. So what else is there? So what's with the underscore error label? We need to have separated between the reporting agent and the reported query. What else is in that report? Well, the queue type and the error. And which errors are we talking about? Those that are in extended DNS errors. Now, to be fair, those are not exactly the same thing, because what you send to a client is basically, sorry, what you send to a stub resolver, those are basically the errors that you'll find out after the whole resolving has been done. But that might not necessarily be the same that you send to an authoritative server when a query resulted in a broken response or in a response that can't be computed, etc., etc. So there's a whole lot in extended DNS errors that we can recycle here. So much so that I don't think it's necessary to open yet another registry with new types of errors. We already had last week during the hackathon a bit of progress on this draft with regards to implementations. So Willem has talked about that. So thank you all who participated. Well, with that, I don't have anything more to talk about with this draft. So I guess I'll give the mic back to you.
Thanks. So Jonathan?
Yep. Thanks. It's an interesting draft. I have some questions. I'm wondering if there's any data around how often there's a failure such that the authoritative is able to respond well enough to give a reporting domain, but not able to actually give the answer to the question. So the DNSSEC example is one. I'd be interested in data around the frequency of other cases. In my experience, the failure modes we see are either the authoritative is just plain offline, or it's perhaps dropping packets based on looking at the query type that it doesn't like or something like that. So I'd be I'm curious about the applicability to things other than DNSSEC example.
Yeah, well, yeah, other than DNSSEC, well, I think DNSSEC is of course one of the failure modes. As long as the reporting resolver receives a response, and of course the authoritative server that sends the response has this agent domain in it, then even lame delegations can be reported this way. That this server is now reporting that it's not responsible for this domain, even though it was delegated to it. So it basically it is only in the case where an authoritative server doesn't respond at all. That's the case when a reporting resolver can't report anything, right? Because it doesn't get this reporting agent domain. In almost all other cases, it has something to report. There are a few things where there's a discussion. If, for instance, with a lame delegation, which side is really broken? Is it the parent or the child? I think that's something we can figure out or even configure eventually. But we're very much in the early stages of developing this and get some experience with this. But thank you for the question.
Jim?
Roy, this is a very neat draft. I like it a lot. I've got one or two concerns about this issue of the reporting agent and what its role is going to be. And maybe this is something that needs to be clarified. Is the role of this reporting agent going to be like the protocol police? And you mentioned in the drafts and in the slides here is to inform the domain owner or operator about an error. Or is the idea that the reporting agent could actually be gathering sort of essentially DNS telemetry data from these field error conditions? I would imagine something like this, for example, would have been very, very useful if we had it in place around about the time of the last root zone key rollover. So I wonder if there's an idea to maybe put some more text of what the expectations are about the role of this reporting agent, and if that's worth considering for a future version of the draft.
Thanks, Jim, for the question. Yeah, that's a good idea. You can use it, of course, for telemetry. Let's say a large resolver constellation If they don't want to send immediately all reports to all authoritative domain servers that it sees as broken, it can actually collect all the data first and then send it on. The idea is not to be the protocol police at all. The idea is basically to just get things fixed when it's broken. I mean, any delay is time wasted. So I remember when I was at Nominet and we had this broken one broken how do you call that? We issued we reinstated the previous DNS key, and that broke a whole lot of things, and we only found out using Twitter at the time that we had a problem. So we could have used this at the time, if that makes any sense. Even though we had all checks and balances there, we still missed this one error. So it's definitely to fix things, not to be the protocol police. Thanks, Jim, for the question.
Okay. Ralph? And you're muted, Ralph.
That's always hard. Hopefully it works now.
There you go.
So in DNS, in a resolver, the name servers are usually identified by IP address. So you get from your draft, you get a reporting agent per IP address, say, yeah. But nobody prevents you to kind of use a domain, to create a domain that points to that name server and is deliberately false or is deliberately broken. So is that a way where we could see, like the NXNS attack, an attack on the reporting agent using that technique? Or are there any kind of things in the draft that I haven't looked at that prevent that?
No, there's nothing that prevents that. But I use the old adagium: you can't stop anyone from sending anything to anyone on the internet anyway. So that's of course you can set up to break things. Keep in mind that the reporting agent, the authoritative server where all the reports come in, that's actually just something where a query comes in and a response comes back, and response is basically an acknowledge that the query was sent. So it's just another server that will it's just another server that will receive information and will respond. It's not going to be an amplifier. No,
but it should. I mean, I think what it should though be, it should be handled differently, because it can easily kind of gather huge volumes of abuse.
I don't understand. Sorry.
Well, I mean, you should just. I mean, if someone deliberately makes a bad domain that generates lots of queries to the reporting agent, then this could be abused. So if you are doing this for your domains, it would be good to maybe have a suggestion in the draft that keep it separate from your regular authoritative name service, because it is easier abused.
Oh, sorry. Yes, that's actually in the draft. The authoritative name server that serves a domain should not be with the agent EDNS0 option, right? Should not be the same server as where the error reports come in. So that's definitely part of it. The whole idea is that is basically a completely separate entity that can handle the errors, and it can figure out eventually using some kind of, I don't know, grep set org, you know, who's responsible for what server, etc. You do that kind of stuff after the fact, right? After you get the error reports in.
Yeah, okay. Yeah, I'll send you something about the abuse scenario that you could maybe have.
Yeah, thank you.
Bernie, and then we'll close the mic line at this one. Go ahead, Bernie.
Hello. So having dealt with network blocking in the last few years, mostly politically, I was wondering what kind of impact this has to network blocking and whether it all works with network blocking and so on. Have you been studying this also a bit?
Yeah, I think network blocking is quite orthogonal to this issue. You first need to get a response anyway from an authoritative server with the EDNS0 option that has the agent domain before you can send a report. So after you've sent a report, that basically meant nothing got blocked, if that makes any sense. All right, thank you all for your questions. Suzanne, back to you.
Okay. Thanks, Roy. And Jim Reed is next with the DOH operator draft. And Jim, I was assuming I would run the slides just to reduce the switching overhead, but
No,
up to you.
I think it's best if you drive the presentation, Suzanne. Fewer moving parts and all that. That'd be great.
Yep.
Thank you. I really want to just start off by sort of setting the scene here. This idea is a revival of a document that was submitted to IETF104 in Prague to the DOE working group, where it generated a lot of discussion. Not all of it was particularly helpful in my view. And we were left at that point, we being the authors of the document, were left in a sort of quandary, because at that stage, the DOE working group was being wound down. There were talks about potentially BOSS for a new working group being set up. So we decided at that stage to sort of wait until the dust settled into all that kind of IETF machinery had actually done its thing, and we saw how things were progressing. But there was definitely, and there still is, a lot of enthusiasm for documenting this stuff and getting this eventually published somehow, ideally as an IETF document. There are some gaps in the document, as there were in the previous version, particularly around things like TLS session parameters and how these might influence the behavior of DOE resolver services. And that's something that could still be worked on if there's enough enthusiasm to progress the document in some way. And of course, the landscape has moved on considerably since IETF 104. There's a lot more experience and insights into what browsers in particular are doing with their DOE settings and behavior. Next slide, please. Sorry, step on another one, Suzanne.
There we go.
Yeah. So, as I said here, the objective here is purely to document the problem space for DOE deployment from the perspective of network operators primarily, but there may be some other considerations here that could apply to other use cases. I'm thinking, say, enterprise networks that may have some concerns around DOE deployment with respect to things like NAT setups and split DNS setups and stuff of that nature. But the main thrust of this is to do with ISPs have got the orders of millions of customers or more, and inside those networks we've got all sorts of CPE and all sorts of weird and wonderful beasties like carrier portals, carrier grade NAT, and of course a whole bunch of regulatory considerations and stuff that applies to the operation of these networks. And of course, in these situations, DOE will have an impact on the existing infrastructure, how things are provisioned, operating procedures, customer support, and all these other kind of stuff. And as I mentioned earlier, I think it's best if this gets documented in an IETF setting. And obviously an RSC is the end game for this. Probably, I think, an informational might be the best way to get this thing done and dusted. Next slide, please. So the question is, why is this draft being submitted, and why are we having a discussion about it now? Well, this is about operator networks and operational considerations in some of these operator networks, and it involves DNS, albeit primarily DNS over HTTP rather than port 53. Can't bring this stuff to the DOE working group, that's gone. It's obviously out of scope for DPRIVE and the ad working groups, so DNSOP seems to be the best place to start, and it does have some overlap with it there. In my view, it doesn't have to become a working group document. It will need, I think, some degree of oversight and review by DNS experts who are some stage removed from the authors of the document and the others that are interested in contributing to the document. So I think it potentially could become an individual submission or an AD-sponsored document or something of that nature. I'm fairly agnostic as to what the best solution is here. And really, I'm asking the working group what they think might be the best next steps. And that takes me on to my final slide, which is where I shut up, and it gives time for everybody else to give their comments and suggestions, throw rotten fruit, send money, send coffee. Over to you.
Thanks, Jim. Benjamin?
I don't I don't think this document is a good fit for DNSOP. I think its contents are very broad, and a lot of it is considering regulatory issues that are and speculating on legal questions that are not in scope for DNSOP. And a lot of the technical content I don't think is really accurate. So I wouldn't want to use it as a starting point.
Mark?
Yeah, I'm much more enthusiastic than Benjamin, I guess. I do think that this is an important document to have somewhere as documenting operational experience. And my past bias is that documenting DNS operational experience is something that is a good fit for DNSOP. But if the chairs don't feel that way, and if the working group doesn't feel that way, then I still think that documenting this needs to be pursued. And so I would be enthusiastic about seeing this go forward. My first preference would be to have it in DNSOP, but if that's not possible, I'd still like to see it move forward under some other guise.
Okay, thanks. Yeah, and I have some comments I'll make at the end, but we'll cut the line after Andrew. But Mr. Farrell?
Hi. I admire the bravery of taking on all the things that were too controversial for ADD, but I don't understand how you could possibly finish this document until ADD has done its work. So I'd be puzzled if this was something that could be adopted right now.
Okay, thanks. Ted?
Ted Hardy speaking. I'm sort of expanding on Stephen's comment in that, although I think that it is both brave of Jim and co to take this on and possibly very important, that the landscape is changing pretty fast, not just in ADD and other places, and that this is probably not the time to write down what we actually think the DNS operations will look like. I think the most that you could do at this time is ask a whole bunch of questions, which you have in sort of like 6 and 7 and other parts of the draft that are more about, here are the considerations, but we're not telling you what the best practice is yet. So I think maybe keep those around, and as the best practices emerge, write down what those are, and then when you have that would be a great thing to document. But I don't think that this is quite ready for publication into an archival series at this point, because the ground under its feet is moving almost as fast as it is. Thanks.
Oh, Andrew? And you're muted, Andrew. Yep.
Yeah, thanks, Tim. I think I agree with, I think it was Mark who came in first. I think the document does serve a useful purpose. I don't see the dependency on the ADD working group work needing to complete first. I think it's entirely valid to document the sort of considerations for operating networks. The ADD working group is just looking at resolver discovery and selection. So I think they can quite reasonably run in parallel. And if, as Ben suggested, there are some inaccuracies in the current draft, then in my humble opinion, those need to be fixed. And again, that's not a reason not to proceed with the document. So I think it's a good document. It's a good starting point. Let's work on it. I'm happy to help with that.
Okay. Ted, you want to get back in there? Nope. Paul?
Going back to the original question of should it be done here, as in DNSOP, I would say probably not, even though it's about operations. It's not the kind of operations, or much of what's in this document, and probably will end up in the end, is not the kind of operations that this working group typically deals with, such as regulatory and interactions with other parts of the system that are not technical interactions and such like that. It certainly, as it progresses, should people like it would make a lot of sense for the document authors to tell DNSOP, hey, we've done a new draft or whatever, but it should have its own mailing list. And I'll agree with some of the people earlier who said it's premature. That doesn't mean like Ted said, that doesn't mean we shouldn't start on looking at the questions, but it's vastly premature to think that we're within months or even seasons away from it being ready. So I would propose it doesn't happen here. But still that it should happen. Thank you.
Okay, thanks. So a few comments. When Jim came to us about this, I sat down and read it, and I understood the operational point of views, but as I pointed out to him, there are parts in there like the policy stuff, which it's got, there's just no place sort of thing. And that will just be a minefield. But there are things that should be documented. And I think, Ted pointed out some of those as well. And it definitely needed to be reworked if we were going to take it on, which I wasn't sure. I also suggested if it looks like we don't take it on, which, working group, he can go independent stream, but then it'll always kind of sort of pass through us to sort of get vetted at some level. But I do agree that some of this needs to be sort of fleshed out. I think what they're looking at is, as you deploy DOE, what do you have to worry about, right? But correct, the policy stuff and things of that nature, that makes me really nervous from a sort of a chair point of view. Go ahead, Jim.
Tim, I quite agree that the policy stuff makes me nervous too. And I just want to make this clear to everybody. There's absolutely no intention of any sort to try and get too involved in policy or regulatory considerations or try to fix those things. These are clearly outside the remit of the IETF. And the only point of having this kind of stuff text in a document list is just to say, these are what the current policy or regulatory considerations might be. And essentially draw a line and say, there be dragons. We're not proposing in any sense to try and solve those policy considerations or recommendations or anything like that, but just so that an operator will be aware of the fact that, you need to think about GDPR. I mean, it might be a statement of the obvious, but things of that nature, these statements need to be written down and expressed somewhere. That's really what we're trying to get at as part of this document. It's certainly not asking the IETF to work on things which are outside its scope.
Okay, go ahead, Ben. We have a few more minutes.
So on the policy point, I'll just say I don't. So I take the point that the draft attempts to describe the existence of certain policy issues without getting too specific about what those exact issues are. But I don't think that this is really our place, and I don't think it's really useful. That is, if we don't have anything concrete or specific to say about policy and compliance, then we're not doing anyone any favors by noting that policy issues exist, especially because when we make mention of these policy issues, whatever they might be, we implicitly we engage a problem that occurs frequently across the IETF, where by documenting anything in an RFC, it's very easy to accidentally lend it the imprimatur of the IETF. And we should be very careful not to imply that certain policy choices are correct or incorrect, or that the interpretation of those policies as binding particular parties are correct or incorrect.
Andrew, we'll let you wrap it up, and then we'll get on to the next presentation.
Okay, thanks. I was just going to just pick up on that last point from Ben. I think it's reasonable to note that the policy considerations can exist in certain areas, not to make recommendations as to what stance to take on those considerations, but I think it's entirely right to highlight that they exist. And by the way, most of them, as I read the document, exist for all resolver operators, whether they're network operators or not. So it will be useful to have them captured somewhere. This document's a good place to capture them. Thanks.
Okay,
Yeah.
thanks all. Yep, go ahead, Suzanne.
Yeah, just to sort of, I thought it would be good to get on the record the conversation that's been going on in the chat also. That we do sort of at some point need to figure out if this is if we're going to say this is not in scope for DNSOP and the ISE does include a conflict review. I have to say that to a first approximation, I don't think that's a problem, because the conflict review is about whether the work in an independent submission draft is in conflict or contradiction to working group work. And what has happened before with conflict review situations is that if we say that the working group had a chance to discuss the draft, had a chance to consider the issues, and there's no specific conflict with other work going on in the working group, that's not a problem. And the point is not to presuppose the outcome of the discussion about the fate of this draft, but only to say that we have a fair amount of flexibility as the working group to determine what work we take on. And if people decide, certainly it's a good idea. It's a good thing that the draft exists and that there's the opportunity to comment on it. But I do suggest people not get too hung up on the specifics of scope and charter, when really the question is, would this document and benefit, and would the community benefit from a commitment from the DNSOP working group? And what I'm hearing is that it's either no or it's too soon to tell. And I'm seeing.
I think we should move on.
Yeah.
I know people are talking about doing a vote, and I'm just terrible at the whole hands thing. So Suzanne, unless you can figure that out, then maybe we'll do that. Maybe we'll do that by the end of the meeting.
Fly.
Yeah, not on the fly. So,
but I've had trouble with that.
I agree with what folks are saying in the chat. It's probably worth
what I would urge. Yeah, what I would suggest is both to the mailing list, if people want to continue the discussion. Also, drop a note to the authors. Private discussion. I'm sure that feedback would also be welcome. And there's a really interesting discussion going on here. So please do feel free to continue it. Thank you. And I guess we're on to the next. So is Fujiwara-san here?
Hello, can you hear me?
Yes.
Okay. This is Kazunori Fujiwara from JPRS. Today I will talk about delegation information referral signer for DNSSEC. It is just an idea, and it may have many problems. Next slide, please. These are my motivations. DNSSEC specifications don't protect the parent-side NSRZ and UL records in the delegation information. It is a missing piece of DNSSEC. Why? Parent-side NSRZ and GRU records are non-authoritative data of parent zone. Parent zone cannot sign non-authoritative data. Authoritative servers can remove a part of GRU records from response packet. GRU records are not well or exactly defined. However, the referral parent-side NSRZ and GRU records are important information specified by customers for TLDs and RRs and root. Currently, TLDs and RRs and root sign DS and NSEC records only. Next slide, please. These are changes from 2005. DNSSEC RFC, when DNSSEC RFC published, the word in domain is defined by DNS terminology. The in domain GRU is necessary and sufficient GRU information for name resolution. And Mark Andrews' draft IETF DNSOP GRU is not optional, proposes that GRU records are expected to be returned as part of referral, and if they cannot be fitted into the UDP response, TC=1 must be set to inform the client that the response is incomplete and that TCP should be used to retrieve the full response. And many DNS software developers understand that referrals GRU records are non-authoritative data. Many DNS operators, including TLDs, RRs, avoid coexistence of parent zone and descendant zones on the same authoritative server. Next slide, please. This is one idea, Delegation Information Signer, DIS. It reuses DS resource record. Assign a new DNSSEC digest type XX Delegation Information Signer with SHA-256, DIS SHA-256. The key tag and others field may require in further discussion. Digest is calculated as SHA-256 hash of parent side NSRZ and in-domain GRU records. NSRZ and in-domain GRU records are ordered as canonical order defined by DNSSEC. Shivering and out-of-basic GRU records are not the data to calculate the hash. And there are another idea. Because shivering GRU is also written in the parent zone, we can generate a digest with all embedded GRU records and need to define. And the parent zone signs DIS resource record as DSRR set. This proposal includes DIS data in the referral responses. DNS validator can validate referral responses. Next slide, please. This example shows DIS resource record generation. First, remove old DIS. Step 1, remove old DIS. Step 2, generate new DIS. 2.1, collect referral NSR set and in-domain GRU. In this example, wide edge response from JPDNS contains 3 NSR set and 1 DS resource record for in-domain GRU. Then step 2.1, collect referral NSR set and in-domain GRU. And step 0.2, reorder NSR set and in-domain GRU as DNS canonical order. Step 2.3, calculate SHA-256 hash. Wide JP NS 3 NS resource record and NS wide A quad A, NS Tokyo A quad A, and generate DS data as DS 00XX and hash, and Next, and step 3, sign DSRR set contains generated DIs and original DS. This is example of DIS resource record generation. Next slide, please. This is an example of DIS resource record validation. When a validating resolver receives a referral response with DSRR set and the DSRR set contains a DS resource record that have DIS SHA-256 digest type, then calculate digest from NSRR set and in-domain group from referral response. And compare the digest and the digest field from the DIS resource record. And if the digest differ, the referral is compromised or modified. The validating resolver can drop the referral. Next slide, please. These are responses, comments from DNSOP mailing list. Who signs? DIS is a part of DSRR set. It is signed by parent zone and it is the same as DSRR set. TLD zone would become big because current DS registration ratio is very low and DIS adds DS, NSEC, and RR6 to all delegations. It is not a problem for TLDs with a high DNSSEC deployment rate, such as .SE. And DNS is loosely coherent. DIS doesn't work when the source of data are not coherent. Many DNS operators, including TLDs, RRs, avoid coexistence of parent zone and descendant zones on the same authoritative server. And in-domain invariant groups are well defined. Next slide, please. This is last slide. I have a question. Why didn't we decide signing referral information, parent side NSRR set and group? Is it a missing piece of DNSSEC? Do you have interest about signing referral information? Do you have another idea? Is it good to reuse DS resource record? Is the delegation information signer idea good? That's all. Please comment.
Peter, go ahead. I know we have a few minutes, so.
All right, thanks. Thank you for writing this draft. I, in fact, proposed something quite like it in Deprive a few months ago. People did not like it at the time, but I feel that something like this might be the key to making authoritative DOT work with TLSA records. So I understand that several people in Deprive are watching this draft with great interest as well. I have some practical comments, but I think I can do those on list. So that's it.
Thanks, Peter. Ben?
I think this draft is very interesting. To Peter's point, it definitely overlaps with a bunch of things that are happening in Deprive. I would definitely move it from DNSOP to Deprive. I think to figure out if it makes sense, we're going to first need to understand the bigger picture of auth DOT to see if there's a place for it.
Okay, thanks. Oh, Jim?
Thanks, Tim. It's an interesting draft. I'm not so sure it's really needed because the child information in the child zone is signed. So it's not clear to me that having some kind of signed metadata for the delegation in the parent over and above the DS record that's there is really needed. And second point I have is, would this DIS record sit alongside a DS record, or it would be is the plan to replace it? My concern here is that we've already got a lot of complicated stuff around zone cuts, and we learned that lesson the hard way with DNSSEC. And I think adding more complexity here could make things even worse. And it's not clear to me, at least at the moment, that we're actually going to get a big benefit from deploying this. I think this needs a little bit more of a cost-benefit calculation to be worked out. Thanks.
Okay, thanks. Peter and Olaf, we've got a few more minutes before I think we drop, so go ahead, Peter. And you're muted. You are still muted, Peter. Okay, I say let's jump to Olaf, and then if Peter can figure out the mic thing, we'll go back to that. How's that?
Suzanne, can you raise your thumb if you hear me? Good. So on that first question, why did we design signing referral information not to sign that? I was, DNSX chair at the time, and I recall that we were very, very careful to not muck about with what we understand of the DNS at the time that we did this work. And the introduction of DS record as an authoritative bit of information about the child was something that that was a little bit of a jump into uncertainty. It turned out to work. It turned out to not have all kinds of side effects, but we were pretty afraid to do that. So I think that is sort of a context of not defining it, was being careful at the time and making the most minimal changes to the DNS while redesigning DNSSEC. Over and out.
Thanks, Olaf. Suzanne, final comments?
Only that we should be saying thank you very much to everyone who participated this week. Both of our sessions have been treating a lot of our participants to jet lag without the travel, which has been awkward, I think, for a lot of folks. So thanks everybody for for attending and discussing and participating. I think we've had some very good work done, and we'll be following up on the mailing list. And I think that's a wrap for IETF 109. Thank you, everybody, and we'll see you out there.
Yeah, thank you all. Thank you all for making it through the night or the morning. Okay, bye now.
And Benno, please feel better.
Yeah.
Thanks, everybody.